Back this morning, and we will continue on with the state's case this morning, and you may call your next witness.
Thank you. The state calls Vicki Beamer.
Thank you, Ms. Beamer. And Ms. Beamer, you continue to be under oath at this time, so I'll have you go ahead and take the witness stand. Thank you.
Oh, you know what?
Okay.
I'm gonna have Mr. Roseberry assist me with that so we can.
Sure.
Okay, good morning.
Good morning.
We already heard, and the jury's heard from you previously, that you are Vicki Beamer.
That's correct.
And we talked to the jury some time ago and told them that you would be testifying twice, so you are here for part 2 of your testimony. Is that your understanding?
Yes.
And they heard you testify back first on December 17th and then on January 5th. You were up on the stand quite a bit. This time it's going to be quite a bit longer. So wanted to cover that with you. During your initial testimony, we discussed your educational background, your training and experience. So I don't want to cover any of that again. The jury's heard that information. I believe during your initial testimony, we also talked about the importance of lab accreditation, quality control measures, and protocols that you as a lab have in place to avoid contamination. Do you recall that portion of your testimony?
I do.
And I believe you also discussed with us that every lab report that's authored goes through both a technical and administrative review process. Is that correct?
That's correct.
The jury also heard last Thursday from Tina Gore. Is that somebody that used to work at the lab with you?
Yes.
Who gave us a quick refresher, given it had been some time. We had heard some testimony about DNA on things such as the importance of how things are swabbed, serology, and then the multi-step process used by analysts when processing items for DNA. And she talked to us about how requests come in, as well as the significance of the dates and how dates on lab reports are not necessarily the dates that you actually get the information, not when the request is actually made.
That's correct.
What I do want to ask you about, though, in a little bit more detail, is a system that you had in place back at the time when most of these items were being tested called iLeads,
Okay.
and how that system impacts how pieces of evidence are assigned item numbers. So when we start going through your PowerPoint and the different items that you tested, we can understand the significance of the chronology of the item numbers.
Okay.
So if you could please explain that process to us.
So iLeads is the police department system. It's a LIMS information system. And when an item is impounded into that system, it's given a unique number, and it's a sequential number. So when that item is entered, it's given a unique number, and then but it's used by the entire department. So although you may be impounding several items of evidence from one case, they may be sequentially numbered. There could be a gap in there if there's another person also impounding evidence into the system, or if there's been a long period of time in the same case where items have been impounded. There could be a big gap in the numbers, since those numbers are sequentially used by the entire department.
To flesh out a little bit what you said about if there's been a long time on a particular case where work hasn't been processed, I think that's pretty easy to understand why there would be a gap in the numbering system. Related to the first point you made, just so I'm understanding correctly, let's say Detective Heinzelman is impounding items of evidence on, we'll just make up a day, January 1st, and then later another detective working another case on that same day is impounding items. Could that affect the sequence of the item numbers that we're seeing?
Yes. It could be that the first case has the first couple numbers back to back, but then the other case has the next number. And then if it's some time and the third item's impounded, it might then have skipped a number in that first case because the other number went to the second case.
Are we going to see examples of that in the PowerPoint where there's a difference in the sequence of numbers on items that appear to have been impounded on the same day?
Yes.
Another thing that I want to talk to you about before we get into the meat of your testimony is it fair to say that from the beginning of this case, when you started doing work, which we established was in February of 2015, to the present, was there a change in the way data related to DNA has been interpreted?
Yes.
I believe from 2015 until April of 2016, you were doing what you, I think, call traditional interpretation or binary interpretation.
That's correct.
Explain what that is.
So that is an interpretation that's manually done by the analyst by looking at the data. Statistics are calculated using that data. In the Scottsdale PD Crime Laboratory, we used a statistic called random match probability for single source samples, and then a statistic called CPI, combined probability of inclusion for mixed samples. So the wording of the statistics back in 2015 are going to be different and appear different and sound different than they did when we went online with probabilistic genotyping, which we went online with April 7th in 2016.
And when you say probabilistic genotyping, because that can be a lot to get out, like I just struggled with right now, is this something that we routinely are going to hear referred to as when you were using star mix?
Yes, we actually use, it's a vendor that makes it. It's an actual software program called StarMix, and it uses probabilistic genotyping.
So as you reviewed your labs that you authored or others authored in this particular case that you're going to be talking about today, I think you established that the very first lab you became involved with was lab request 23, and then the binary or traditional type of statistical interpretation carried on until about lab 80. And then at some point from lab 96 forward, did you determine that that's when Scottsdale Police Department's crime lab started utilizing StarMix?
That's correct.
Okay. So I have what's been marked as Exhibit 24 and Exhibit 25, which appear to be yours. And then I also have Exhibit 23, which contains other lab reports. I'm going to approach if that's fine.
Yes, you may.
This might be a silly question, but did you author a lot of reports in this case?
I did.
Okay. Now, the reports themselves don't tend to be terribly lengthy. Is that fair?
That's correct.
There are other things that you have in that binder that accompany the actual reports.
That's correct. All my case notes and documentation from the case, any instrument sheets, anything that was any piece of paper that was related to the authoring of that report is also part of my note packet.
And is that something, as an example, that gets given to the lawyers as well with the reports?
That's correct.
Given that you authored a lot of things, I'm assuming it would be humanly impossible to have everything that is in those reports committed to memory.
That's correct.
So in the event that you need to refer to a report to refresh your recollection as we are moving through, please just let me know and we'll give you the opportunity to do that.
Okay.
Like the first part of your testimony, did you assist myself in preparing a PowerPoint to try to visually assist your testimony?
Yes.
All right, I think I've covered the background stuff that I want to cover with you, so I want to now move into the work that was done in this particular case. We mentioned, and let me know if you have this in front of you, I'm going to be talking about lab request 23, which we've already established is the first lab request that came in or that was authored by you.
I'm going to have to refer to the notebook.
And I believe they should be tabbed by number.
Yes, I'm looking at request 23.
Okay. So the first thing I want to ask you before we before we discuss the substance that's on the slide is, could you please tell us the date of the original report that was issued?
The date the original report was issued was February 25th, 2015.
Now, is there a different date on that particular lab request besides that February 25th, 2015?
There is.
What is that date?
That is July 13th, 2015.
Could you please explain to us the reason why the original report was issued on one day and then the final date is July 13th of 2015?
Yes, the original report was amended due to a typo of one of the reference samples person's name.
Who are we talking about?
Talking about Alex S.
So if I'm understanding you correctly, it was spelled incorrectly. You realized that at some point and then went back and made an adjustment?
That's correct, and then corrected the last name, and so on the report, it's actually bolded to indicate that's what changed from the first report.
Other than simply correcting the spelling of Alex's name, was there anything else amended in this report?
No.
I want to talk to you now about what things were processed during this initial lab request. And I'm going to start with, in your report, let me ask you this. Is there a section where you have subtitles called results and/or conclusions?
Yes.
So I'd like to talk to you first about some results that you determined and documented in this particular report. In terms of the PowerPoint, do you see a departmental report number listed on the PowerPoint slide and in your report?
Yes.
And is that 15-04116?
That's correct.
To confirm, is this a departmental report number that stays with this case for the entirety of its case?
That's correct.
Does that number ever change?
No.
It looks like as part of this report, you looked at items from a sexual assault kit that you received from the autopsy of Allison Feldman.
Yes.
And then You also looked at certain swabs that you testified about during the first part of your testimony, which were PMX, PMY, and PMZ. Do you recall talking about on December 5th when you testified going out to the scene and collecting swabs from the victim's body?
Yes.
Are the X, Y, and Z the swabs that you collected from her body?
Yes.
So you took swabs from the sexual assault kit as well as swabs that you had processed, and then you looked for what?
I looked for semen.
In terms of the sexual assault kit, what was your conclusion?
No semen was identified on any of the items from the sexual assault kit.
And I think you indicated that no spermatozoa was observed. Is that a different test, or do you have to do a different visual inspection or something to do that?
When I say that no spermatozoa was detected, it was because I was looking at the slides that the nurses prepare in the sexual assault kit. So that test, I'm only looking for sperm, where when I say semen was not present, I also did a presumptive test for acid phosphatase in addition to searching for spermatozoa.
So if I'm understanding correctly, you did the that test that you just discussed, and then you also took slides, put them under a microscope to get that second conclusion.
Well, yes, for this, let me clarify. For the semen test, I do an acid phosphatase test, which is a preliminary test for acid phosphatase, which is found in high quantities in semen. And then I prepare my own slides from that sample. In the sexual assault kit that's collected from the same nurse, they also collect samples and they prepare their own slides. So when I say spermatozoa was not observed on those items, I'm speaking about the slides that the same nurse collected.
Okay. And then moving on to the other swabs, the ones that you collected at the scene that you testified about back in December of last year, what was your conclusion related to those?
That no semen was identified. And I should clarify, usually sexual assault kits are collected by sane nurses, but because the victim was deceased, it was collected by the medical examiner.
And when you say a sane nurse, is that a sexual assault nurse examiner?
It is.
Do those nurses typically work with victims that are still alive?
That's correct.
I want to move on to the next slide. Now, you mentioned when you testified back on December 5th that while you were at the Feldman residence late hours of February 18th into the early morning hours of February 19th of 2015, that you swabbed and or collected 26 stains or items. So with respect to the slides that we're about to cover, is this the testing that you did related to those initial 26 items?
Yes, it is. I don't know that all 26 items are part of this report by memory, but I know it contained the majority of them.
At some point, did some of those other items get tested at a later date?
That's correct.
So I want to start with what we have up there, which is PMA, PMD, PMM, PMP, and PMR. A, D, and M in those slides appear to be apparent blood. R is a cutting from the couch, and then P appears to be a piece of glass that was located at the scene. With respect to these 5 items, I'd like to talk to you about what your conclusions were.
Okay. For those items, the DNA profile obtained from PMA, PMD, PMM, PMP, and PMR match the DNA profile obtained from Feldman at all genetic loci tested. No foreign DNA was detected. The frequency of occurrence among unrelated individuals of this DNA profile at 15 loci is approximately 1 in 1.54 times 10 to the 19 individuals.
That's a big number?
That's actually a very small number. It's 1 in that number, so it's that statistic demonstrates how rare that profile is.
Meaning Allison's profile.
That's correct.
Two things with respect to your conclusions there. Were you able to identify or not identify blood on these particular items? And if you look at the results section, I think they're discussed there.
Yes, blood was identified on all of those items.
Now, you mentioned the rarity of Allison's profile. Another thing that you pointed out was that there was no foreign DNA detected. When you say no foreign DNA detected, what does that mean?
That means that there was no other DNA from anyone else detected on those items. They all appear to be from a single source person.
I want to move on to the next slide, which covers PMG as well as PMQ. So I'd like to talk to you about what your results are when you examined the swabs from these two stains.
So for PMG, the DNA profile obtained from PMG matches Feldman at all genetic loci tested. Indications of a possible minor contributor were obtained at one locus, and no conclusions can be drawn to the minor contributor due to the limited genetic information obtained.
What about PMQ?
For PMQ, the DNA profile matches Feldman at all genetic loci tested. Indications of a minor contributor were obtained from 3 loci, but again, no conclusions can be drawn about the minor contributor due to the limited genetic information obtained.
Was blood identified on these items or these swabs?
Yes.
Now, you mentioned that for both of these items, it appears to be a mixture, and Allison Feldman was the major part of that mixture.
That's correct.
And that with respect to PMG, there was indications of a minor contributor at one locus, and for PMQ, indications of a minor contributor at 3 loci. When you only have one locus or 3 loci, is that really able to give you any information?
No, not really. It's too limited, and I don't. Once it's too limited, I can't really compare it to any reference samples.
In terms of being able to draw a conclusion?
That's correct.
Moving on to PMH. You testified, I believe, on December 5th, simply about this particular swab and the profile that you generated from this swab. So if we could talk about the conclusion there, the overall conclusion.
So for PMH, blood was not identified on that item, and the DNA profile obtained was from an unknown male contributor, number 1. Alex S. and Pfeiffer are excluded as possible contributors. Indications of a minor contributor were obtained at one locus, but no conclusions can be drawn about the minor contributor due to the limited genetic information obtained.
Now I have a question. When we talked about Allison and her being, you were able to provide a stat.
Yes.
And you talked about how rare the profile is. When you're talking about PMH in this instance or some of these other conclusions that you've talked about, why are you not, in every situation, able to provide a stat?
A stat is not provided unless I actually have the reference sample from that individual. So in this case, there was a profile, and it was identified as just, generally speaking, unknown male number 1 in the case.
So let me clarify this a bit. When you were able to provide the stat for Allison, it's because at some point you had a buccal swab that you knew was her.
Correct.
In this instance, if I'm understanding you correctly, because you did not know the identity of unknown male 1, you are unable to provide a stat for that reason.
That's correct.
Before we move into some of the other results from some of the other items, when we talk about your conclusions, we're going to hear you speak of things called gender markers. So I want to talk to you about what gender markers are, and when you're looking at all of the locations, are there certain markers that you're looking at to determine whether somebody is a male or female, things of that. So if you could explain what we're looking at on this particular slide, which is slide 6.
So the gender markers in the amplification kit that the Scottsdale PD uses are circled in red. The first one I want to discuss says amyl, which is short for amlogenin. And in females, the result for amlogenin would be XX, and for a male, it would be XY, because males have a Y chromosome where females do not. The other 2 markers, Y-indel and DYS391, are male-specific markers. So if a result is obtained for one of those loci, it lets me know that there is at least one male individual that is comprising that DNA profile.
I'm going to move on to the next item that you looked at as part of this request, which was PME, or item number 1019232, which was pieces of glass near the wall. Can you talk to us about the conclusions you reached when you processed this item?
Yes. A partial mixture of DNA profiles from at least 2 individuals was obtained from PME. Results were obtained at 4 loci in addition to 2 gender determination markers. The remaining 11 loci gave inconclusive or no results. Alex S., Feldman, and Pfeiffer are all excluded as possible contributors. Unknown male number 1 cannot be excluded as a possible contributor.
I have a couple questions related to the conclusions you just shared with us. First of all, when you say results were obtained at 4 loci in addition to 2 gender markers, you mentioned looking at gender markers. When you say 2 gender markers, does that mean 2 separate males, or could that still just be from one male?
It could be just from one male.
The other question I have is when you say unknown male 1, or PMH, cannot be excluded as a possible contributor, what does that mean?
It means that allele types from that individual were present in the mixture, and therefore I could not outright exclude that person as being a contributor to the mixture.
And when you say in that second paragraph, the remaining 11 loci gave inconclusive or no results, what are you telling us when you say that?
Basically, I couldn't deem any information from those locations.
Is that the same as essentially not having enough genetic material?
Yes, either no results or very limited results were obtained from those locations.
Moving on to PMK, or item 1019252, which we heard about previously from you, which was a piece of tape from the dining table. What were the conclusions when you processed this particular item?
A partial DNA profile was obtained from PMK, which gave results at 12 loci in addition to amlogenin, the gender determination marker. Inconclusive or no results were obtained at the remaining 11 loci tested. Feldman cannot be eliminated as a contributor, and no foreign DNA was detected.
Want to break that down a bit too. We're going to hear that there is a mixed profile for some of these results, and then in some of the results, we're going to see a partial mixed profile. Can you explain the difference between when you're saying a mixed profile versus, in this instance, you mentioned that there was a partial profile?
Yes, so a profile can be single source, which is from a single individual, or it can be mixed, which is a mixture of at least two people, sometimes more than that. When I say partial, that means that I didn't get DNA results at all of the locations I tested. Usually that's because the sample is low level and I didn't get data at all of the locations that it was tested. So if I say partial profile, that's a partial single source profile. If I say partial mixed profile, then that's a partial profile from a mixture of individuals.
So if I'm understanding your results correctly here, you obtained a partial single source profile, and because you didn't have information at all the locations, you were not able to completely eliminate Allison as a contributor?
Yeah, I found no DNA that was foreign to Allison.
Moving on to the next item that you processed, swabs from the laundry switch, or the switch near the laundry room, which is PMV 1019303. Can you share with the jury what conclusions you reached when processing this item?
Yes, so a mixture of DNA profiles from at least two individuals was obtained from PMV. The major contributor matches Feldman at all genetic loci tested. Indications of a minor contributor were obtained at 7 loci in addition to amlogenin. Pfeiffer is excluded as a possible minor contributor. Due to the limited information obtained from the minor contributor, it is inconclusive as to whether Alex S. and the unknown male contributor 1 is included or excluded as a possible minor contributor.
I want to ask you a couple questions about this. So when you say that the minor contributor, you saw evidence of at 7 loci in addition to the gender marker, is this what's telling you that the second part of that mixture is a male?
That's correct.
You mentioned that Mr. Pfeiffer was excluded, and then you say it's inconclusive as to whether Alex and PMH are excluded or included as a possible minor contributor. That's a lot of words. What does that really mean?
That means I can't tell one way or the other whether they're included or excluded. So it's just basically I cannot make a conclusion regarding those two individuals.
Moving on to item number 1019304, which is also PMW, pieces of broken glass. In your particular report, you mentioned that this item will be subject to an additional report. We have up here lab request 63. Could you explain what this means?
Yes, when I went to the laboratory, I started working on this evidence and realized that this item was not requested in the original lab request. So I held off on reporting the results until a further request was received for that item.
With respect to lab request 23, did we discuss the entirety of the processing that you did related to the items we just discussed?
I believe so, yes.
I'm now going to move on to lab request number 26. And the first thing that I want to ask you about is, when was the original report authored for lab request 26?
The original report date is March 12th, 2015.
Was this report later amended?
That's correct.
And what was the date that that final report after the amendment was issued?
7/13/2015.
In what way was the original report that you issued amended?
The date that the buccal swab from Allison Feldman was reported was changed from the original report.
Other than that, were there any other amendments?
No.
Now, the jury heard, when we had extensive testimony of things that were located at the scene, that there were sunflower seeds that were found on the cool decking of the cool deck of the backyard. And those are items that are depicted with placards 3, 4, 5, 6, and 7 in the photo. And then there is a photo marker 21, which the jury learned through testimony was a seed that was found in the threshold of the doorway leading from the kitchen to the backyard. Did you receive all of these items to test, or was it requested that you test all of these items as part of lab request 26?
Yes.
I'd like to talk to you about the conclusions that you reached when processing these items.
So for all of the sunflower seeds, with the exception of photo marker 21, which was item 1019348, the DNA profile obtained from those sunflower seeds, the major contributor, oh, I'm sorry, I was looking at the wrong. The DNA profile obtained matches the DNA profile from canast at all the genetic loci tested. The frequency of occurrence among unrelated individuals of this DNA profile is approximately 7.7 times 10 to the 19 individuals.
With respect to that, did you have, because you provided a statistic right there, did you have a reference sample for this individual Heath Canast?
I did.
And was it learned that this was Allison's pool day?
Yes.
Now, with respect to PM21, we see a little bit of a different result. So explain that.
So for item 21, the conclusion is a mixture of at least 2 individuals was obtained from photo marker 21. The major contributor matches Feldman at all genetic loci tested. Indications of a minor contributor were obtained at 9 loci in addition to amylogenin. Canast cannot be excluded as a minor contributor at 8 of those loci. The probability of selecting an unknown unrelated individual at random who would be included as a possible minor contributor to the DNA mixture is approximately 1 in 3,890 individuals.
I want to break that down a little bit as well. So I think it might be interesting to the jury because we have sunflower seed shells. And with respect to the items 38 through 42, we know typically that people will eat sunflower seeds and then spit them out. So we can make heads or tails of why Heath Canast would be the person contributing the DNA on those seeds. For PM21, you mentioned that Allison that it was a mixed profile and that Allison was the major contributor and Heath Canast was the minor contributor. Can you explain a possibility for that type of result?
Objection, foundation.
I'm going to overrule it, limited to her scientific training.
Since the house belonged to Allison, it can be assumed that her DNA is present probably at her house and in thresholds of doorways, or that potentially blood at the scene. That could be one reason why there's a mixture of DNA.
Now, when you mention also blood that we've learned through testimony was Allison's already, we've heard. Is that a bodily fluid that is a rich source of DNA?
It is.
When you see an item mixed with a rich source of DNA, based on your training and experience, can sources that are rich in DNA overwhelm other DNA?
Yes.
And if there's a better way to explain that than the way I asked the question, feel free to do that.
It's just that blood and sunflower seeds, if one is assuming they're spit out of the mouth, has saliva, which also can be a rich source of DNA. It just is going to be dependent on how much DNA is present on that sample.
Moving on to another item that you looked at as part of Lab Request 26, which was 101-9727. The jury heard testimony that a piece of a fingernail was located at the scene of the Feldman residence. Can you discuss for us the conclusions that you reached when processing the nail?
Yes, the DNA profile obtained from the fingernail piece matches the DNA profile obtained from Feldman at all genetic loci tested. No foreign DNA was detected.
So you did not find PMH on that nail?
That's correct.
Moving on to the beer bottle, or the piece of the beer bottle. The jury heard testimony that back on February 21st of 2015, that the police located a neck portion, a broken portion of a broken beer bottle under a couch. And when we're looking at the item numbers there, it was impounded as 101-9867, and then it looks like it was broken up for purposes of your testing to A and B. Can you explain that?
Yes. Part A is the broken bottle, the cap end, and I designated part B as the other end of the bottle.
And so did you then have conclusions for each portion that you processed?
I did. I processed them separately, so they have two different results.
I'd like to talk to you first about the conclusion you reached with respect to A, which was the cap end.
Okay. A mixture of DNA profiles from at least two individuals was obtained from broken bottle cap end A. Item Feldman and unknown male contributor 1 cannot be excluded as possible contributors to this mixture at all genetic loci tested. The probability of selecting an unknown unrelated individual at random who would be included as a possible contributor to this DNA mixture is approximately 1 in 2.03 times 10 to the 8 individuals.
And this is for piece A.
That's correct.
Now here, you gave a stat.
Yes.
And you talked about not still knowing at this point the identity of PMH.
Yes.
How are you able to attribute a stat to this particular result?
Because I had Feldman's profile and it was a mixture, the way that the calculation is for CPI, I was able just to determine how rare that profile would be for someone to be included as a contributor to that mixture.
So if I'm understanding you correctly, there are instances, if you know the identity of one of the people contributing to the mixture, where you can generate a statistic?
It really depends lab-wide what the policy is. Some laboratories will report a statistic even without a reference sample because there is just, it's determining how rare that profile is. So who it belongs to may not make a difference to a laboratory. Our policy is typically we don't give a statistic unless it's a mixture. We're doing CPI at the time.
Which is why when we have instances where we're just talking about PMH, you are unable to attribute a statistic at this point.
That's correct.
I want to move on to the conclusion that you reached regarding the broken end, or part B of the bottle.
A mixture of DNA profiles from at least 2 individuals was obtained from the broken bottle at the end piece, which was B. The major contributor matches Feldman at 19 of the genetic loci tested, in addition to amylogenin, the gender determination marker. Feldman could also not be excluded at 2 loci, which could not be resolved into a major and minor contributor. Unknown male number 1 could not be excluded as a minor contributor at 12 of the genetic loci tested, in addition to 3 gender determination markers, and at 1 locus that could not be resolved into a major or minor contributor. 6 markers did not indicate a minor contributor.
Okay, that's a lot of science.
Yes.
So can we break that down in the most simple way possible?
Yes. So Allison Feldman, I was able to determine that there was a major and a minor contributor for most of the locations that I tested for that sample. Feldman matched the major contributor where I could do that. There were other loci where I could determine a minor contributor, and at that locations, at 12 of them, unknown male contributor 1 could not be excluded. But there were some locations based on what the data looked like that I couldn't really determine who was the major or who was the minor contributor at those locations.
So not enough material or information?
Not enough information.
One question I just want to ask, since we have his finger in the bottle in this photograph, and we heard testimony that that finger belongs to Detective Heinzelman, did you find him on this item at all?
No, I did not.
I now want to move on to lab request number 33. The first thing I want to ask you about is, what was the original date that you authored this particular report?
The original date was April 6, 2015.
At some point, did you amend this report?
I did.
When was that done?
On July 14th, 2015.
Could you tell us in what way the original report that you issued was amended?
Again, it was the spelling of Alex's last name.
So if I'm understanding you correctly, because we've heard this a couple times, essentially once you caught the spelling error with Alex, you went in and fixed all the reports that contained that same spelling error?
That's correct.
So the jury kind of got to see how this went with Tina Gore when she testified on Tuesday, and there was a fair amount of samples that you analyzed as part of lab request 33. Is that correct?
Yes.
Okay, so I have to cover all of these with you. We heard testimony, or are going to hear testimony, that a DNA sample was collected from Raymond Barrero, who we learned was a neighbor and a patrol contact as part of the investigation. Did you process a DNA sample for a person by that name and then compare it to PMH?
I did.
What was the result?
That Barrero was excluded as a possible contributor to PMH.
We also heard from Allison's boss, and he mentioned he provided a DNA sample and the police collected that. His name was Jeff Chardy. Did you process a sample for a person by that name and then compare it against PMH?
I did.
What was the result?
Again, he was excluded as a contributor to the major profile from PMH.
The jury heard testimony regarding a person by the name of Reza Jamshidi, Jamshidi, who was a guy who was potentially harassing people at the Starbucks and mentioning information about Allison Feldman. At some point, a DNA sample was collected from him. Did you process a DNA sample for a person by that name and then compare it to PMH?
I did.
And what was the result?
They were excluded as a possible contributor to the major contributor to PMH.
We heard testimony from Detective McCabe in this trial that he went and contacted 4 firefighters who made entry into Allison's home during the investigation. They were Arrington, Gonzalez, Murrell, and Vaughn. Did you process DNA samples for all 4 firefighters but with those names?
I did.
Were they then compared against PMH?
Yes.
And what was the result for all 4 of them?
All 4 of them were excluded as possible contributors to the major contributor of PMH.
We also heard testimony about a Chad Irwin, who was a neighbor in the area who had lived in a tent, and that police collected a DNA sample from him. Did you process a sample for somebody by that name and then compare it to PMH?
Yes.
What was your conclusion?
Again, he was excluded as a possible contributor to the major contributor of PMH.
We also heard testimony about an individual by the name of Timothy Cox, who was listed in Allison Feldman's cell phone as an electrician. Police collected a sample from him. Did you process a sample by a person of that name
Yes.
and then compare it to PMH?
Yes.
What was the result?
They were excluded as a possible contributor to the major contributor of PMH.
Police also collected, we heard testimony, a sample from another individual who worked along Timothy Cox by the name of Clyde Neal, Kneale. Were you provided with a DNA sample for a person by that name, and then did you compare that to PMH?
Yes.
What was the result?
He was excluded as a possible contributor to the major portion of PMH.
We heard testimony or are going to hear testimony about a person by the name of Andrew Daniels, who was a painter in the neighborhood who had a DNA sample collected by police as part of this investigation. Did you process a sample for a person by that name
Yes.
and then compare it to PMH?
Yes.
What was the result of that?
They were excluded as the major contributor to PMH.
We also at some point heard testimony, I think in maybe the initial stages of Detective Heinzelman's testimony, and we'll hear from him again about a DNA sample collected in the investigation from a Thomas Mello, Mello. Did you process a sample for a person by that name and then compare it to PMH?
Yes.
What was the result?
They were excluded as the major contributor to PMH.
We talked about Heath Canast and the sunflower seeds, the pool guy, and that police had collected a sample from him. Did you process a DNA sample for him separately from the sunflower seeds
Yes.
and then compare it to PMH?
Yes.
What was the result?
He was excluded as the major contributor to PMH.
Again, we heard testimony about police collecting a sample from a person by the name of David, and I'm just going to spell the last name, Baligian, who was a neighbor in the area. Were you provided with that sample, and did you analyze a sample for a person with that name?
Yes.
and then compare it to PMH.
Yes.
What was the result?
They were excluded as the major contributor to PMH.
We also heard testimony during the trial that there were a lot of neighborhood canvases and that detectives and or patrol officers were contacting people in the community and asking for samples, and that a sample was collected by a person by the name of Justin Hounshell, Hounshell. Did you process a DNA sample for a person by that name and then compare it to PMH?
Yes.
What was the result?
They were excluded as the major contributor to PMH.
Moving on to the last three as part of this request, the jury's heard a lot about a person by the name of James Castellamidis, a person who worked at a pharmacist at some point that Allison frequented, and this was a first sample that was provided. Did you process a DNA sample from a person by this name?
I did.
Did you then compare that to PMH?
Yes.
What was the result?
They were excluded as the major contributor to PMH.
We heard about a Jason Stevenson, who was a handyman in the area that was listed in I believe he might have come up in Allison's contacts. Did you process a sample for an individual by the name of Jason Stevenson
Yes.
and then compared it to PMH?
Yes.
And what was the result?
They were excluded as the major contributor to PMH.
And then finally, in Lab Request 33, we heard testimony from Detective Scott Carpenter, or retired Detective Scott Carpenter, that he collected a sample at some point from a person by the name of William Cruz, Kruse, who was a contract worker. Did you process a sample for a person with that name?
Yes.
And what was the result?
They were excluded as the major contributor to PMH.
Now, I want to talk to you about the language that you're using when you're saying he was excluded, each of these people was excluded as the major contributor to PMH. What does that mean?
Well, if you remember, I said that the PMH was a mixture of two individuals and that there were indications of a minor contributor, but it was too limited to make comparisons to. So all of these individuals that I tested were compared to just the major portion of that DNA profile.
And when we're talking about this mixture, at some point, did you put a ratio to it?
Yes, once we did star mix testing, yes.
Okay. And I might just ask you about that now, if you remember, in terms of who contributed what. When we're talking about this ratio, what do you recall it being?
Well, star mix did tell me the mixture proportio, but I can look at the profile myself and determine approximately what the mixture ratio was. And it was about a 99-1, meaning that 99 out of 100 parts of that mixture, 99 belonged to the major contributor and 1 part was to the minor. So it was mostly a single source sample with just indications of a minor contributor at one locus at that point.
Does that account for the confidence that you have in being able to exclude all of the individuals that we've just discussed?
Yes, it was basically a full single source profile.
I want to move on now to Lab Request 37. Can you tell us first the date that you issued this report?
March 12th, 2015.
With respect to this particular lab request, it looks like you were looking at 2 items. 101-6357, which was a swab of a red substance, as well as, I'm assuming, a separate swab since it has a different item number, 101-6358. Is that accurate?
That's correct.
And I think there was some notation in your report that these swabs came to you, but they were not associated with this particular police report originally.
That's correct. They were associated with a different department record number.
So since this is the first time we're seeing and/or hearing testimony about the lab processing items of evidence that were collected regarding a separate case. Can you explain how that process works?
Yes. Sometimes a item from a different case will be asked to be compared to a different department record case. So in this case, those two items, 1016357 and 1016358, were actually impounded under DR 15-02914 and was asked to be compared to PMH.
And what were the results of that testing?
That the results were obtained at only one locus from 1016358, and the remaining loci tested gave either inconclusive or no results. And unknown male number 1 was excluded as a possible contributor, and that profile did not meet CODIS eligibility requirements.
2 questions. So when you're saying that PMH is excluded, meaning that whoever might have been involved in that burglary that was being investigated under this other departmental report, it was not PMH.
That's correct. It was excluded.
And then you mentioned an additional sentence at the end in your conclusions about not being eligible for CODIS. Can you explain? We heard from Tina Gore about all the different databases and that there are requirements in terms of what can go in and what can go out. So could you tell us why you reached that conclusion?
Because only results were obtained at one locus, and just because you may hear reports that say CODIS entry or not CODIS entry, throughout the years, we kind of changed our reporting process. At some point, we would always state whether something was entered into CODIS or not, and then in other years, in the future, we would only say if it was entered into CODIS. So some of the report language has changed over the period of 10 years.
And I think Tina told us not necessarily just CODIS, you would document whether it could be or not be put into the local database, the LDIS.
That's correct.
And I'm just using that as an example. We heard about multiple databases.
Correct.
Moving on to lab request 40, where it appears that you looked at another grouping of buccal swabs that were collected in this particular case. First, could you please tell us what date you issued the report for lab request 40?
It was April 3rd, 2015.
So again, similar to how we kind of did lab request 33, we either heard or will hear testimony that there was a DNA sample collected for a person by the name of Maher, M-A-H-E-R, O'Day, O-D-E-H, as part of the investigation. It was a patrol contact. Did you process a DNA sample for a person by that name and then compare it to PMH?
I did.
What was the result?
They were excluded as the major contributor to PMH.
We also learned that police collected a sample from a person by the name of Daniel Navarro. Again, another patrol contact, possible burglar. Did you look at a sample for a person with that name and then compare it to PMH?
I did.
What was the result?
They were excluded as the major contributor to PMH.
Another individual had a sample collected by the name of Robert Hutto, H-U-T-T-O, another contact by patrol. Did you process a sample for a person by that name and then compare it to PMH?
I did.
What was the result?
They were excluded as the major contributor to PMH.
We heard that police collected a sample from a coworker of Allison's. We heard from detectives as well as from Allison's boss, Jeff Chardy, about Joe Paddock. Did you process a sample for a person by the name of Joe Paddock
Yes.
and compared it to PMH?
Yes.
What was the result?
He was excluded as the major contributor to PMH.
We also heard about a person named Thomas Napper Nat who had a DNA sample collected. I saw a typo somewhere, so I'm going to rely on you for the accurate name. Who was a soft water system tech that was contacted by a Detective Weischer. Did you process a sample for a person by, and if you could tell us the correct name?
The spelling I have in my report is KNAPP.
Did you compare that to PMH?
I did.
What was the result?
He was excluded as the major contributor to PMH.
We heard that Detective Carpenter had collected a sample from a person by the name of David Prusak, who was affiliated with Cox Security. Did you process a DNA sample for a person by that name and then compare it to PMH?
Yes.
And what was the result?
He was excluded as the major contributor to PMH.
We learned that police, through the various reports, had obtained a DNA sample from a person by the name of Kevin Drum, who was a patrol contact for possible stalking behavior. Did you analyze a sample for a person by that name
Yes.
and then compare it to PMH?
Yes.
And what was the result?
He was excluded as the major contributor to PMH.
We also heard about an individual who was contacted at the Playa Bar by Detective Scott Carpenter by the name of Brent Roberts. Did you process a DNA sample for a person by that name and then compare it to PMH?
Yes.
And what was the result?
He was excluded as a major contributor to PMH.
We also heard about the collection of a DNA sample during this investigation from a person by the name of Brian McCartan, who was a neighbor and brother to one of Allison's really good friends, Katie. Did you process a DNA sample for this individual
Yes.
and then compare it to PMH?
Correct.
And what was the result?
He was excluded as the major contributor to PMH.
And then there was another person by the name of Matthew Mulholland, who was a neighbor in the area that Detective Heinzelman collected a sample from. Did you analyze a DNA sample for a person by that name and then compare it to PMH?
Yes.
And what was the result?
He was excluded as the major contributor to PMH.
I want to talk to you about one more lab request that I think we can fit in before the lunch break. This is lab request 47. The first question I have for you is, could you please tell us on what date you issued the report?
The report was issued on April 6, 2015.
Now, this is item 1022898, and the description of this particular item is a sonic cup with a straw. We talked about surreptitious samples during the trial. We heard testimony from various police personnel about this. And we also heard from Tina Gore on Thursday that when you as a lab don't have a known reference sample, I think you're just looking at the DNA that you may or may not find on an item and then compare it to an item of evidence that you're trying to either see if that person or DNA can be included or excluded. Is that an accurate summary of what you do?
Yes.
So in this particular case, could you tell us what conclusions you reached when you analyzed this particular item of evidence?
Yes, the DNA profile that was obtained from the straw is excluded as a possible contributor to the DNA profile obtained from PMH.
One question I have from you, are you doing the swabbing?
I would have to check my notes on this sample particularly. Sometimes the swabbing could be done by me, but if it, the fact that it says sonic cup with straw, I will assume that it was actual sonic cup with a straw and not a swab from that. And so I would have swabbed the item myself.
And then if you could just tell us, I'm assuming because you talked about the result from the straw, what you'd be focused on with respect to this item of evidence why you would have selected a straw, or did you swab from the whole cup? And if you need to refer to your report for those specifics.
Yes, let me verify. I actually did not take a swab. I cut the end of the straw and placed it into a tube.
Okay, since we have a second, how does that work?
I just extracted the DNA from, instead of it being a swab piece, it was a piece of the straw that was in the actual tube that I extracted.
Understood. And then you were able to exclude whatever DNA you were able to pull off from PMH?
That's correct. The DNA that I obtained from the straw was excluded as the major contributor to PMH.
Perfect time to stop, Judge.
Okay. Ladies and gentlemen, we'll go ahead and take our lunch break. Please remember that admonition, and we will see you back here at 1:30.
Please rise for the jury.
at a series of buccal swabs again to compare against the PMH profile. So the first thing that I want to ask you about lab request 50 is, can you tell us what date you authored this report?
It was April 3rd, 2015.
I want to now ask you about the individuals that you looked at with respect to this particular request. Police obtained a DNA sample at some point based on the notes in your report for a Daniel Lee Curley, C-U-R-L-E-Y, and a Niles Curtis Utley, U-T-L-E-Y, that were two individuals contacted regarding an unrelated case. And DNA samples were looked at by you. Did you analyze samples for two individuals with those names?
I did.
And then did you compare them against PMH?
Yes.
And what was the result?
Both individuals were excluded as the major contributor to PMH.
We learned that police, as part of the investigation, collected a DNA sample,
Together.
So basically, similar to what you've testified previously, you combined them to try to have the best chance of obtaining a DNA profile?
That's correct.
In doing that, were you able to get a DNA profile?
I did.
And were you able to then compare that profile against PMH?
Yes.
And what was the result?
I actually got a mixture of at least 3 individuals from that item. The major contributor and the minor contributors were all excluded as possible contributors to the major DNA profile obtained from PMH.
Moving on to lab request 77, if we can start.
I think we're in a different binder now.
Okay, let me give you a second to. Let me actually get that out of your hair.
Did you say request 86?
No, I said request 77. We have learned, or we know from purposes of the fact that it's reaching you, that a DNA sample was collected for an individual by the name of Darren Smith, who was contacted by a detective at some point and provided a sample related to this investigation. Did you have the opportunity to perform analysis on a sample for a person by that name and compare it against PMH?
Yes.
And what was the result?
He was excluded as the major contributor to PMH.
I now want to move you to lab request 78, which is not going to be in that binder. And before I start talking to you about this, I want to cover a few things with you. First of all, you've been at Scottsdale for a lot of years, I think we established at this point.
Since 2007, yes.
So during your tenure and while this case was being worked on, was there an analyst at Scottsdale Police Department that worked in your department by the name of Steve Clemens?
Yes,
And did he do work in this case?
he did.
Is he now deceased?
He is.
In order to be able to work in your department, does any person, which would include Steve Clemens, have to have the requisite education,
Yes.
the requisite training,
Yes.
the requirement to continue to keep up to date on DNA literature and attend continuing education,
Yes.
subject to the same quality control measures, things like that?
Yes.
Similar to what you've described, in terms of work that he may have done, would his reports be the same as yours, meaning that any report that he had generated would have been subject to the same administrative and technical review that any report you authored would have been subject to.
Yes.
Given you are the technical lead or in more of a supervisory role over at the lab, did you perform some of those reviews on his work?
I did.
And since he is deceased and unable to be with us, there are some reports he authored that we discussed we would provide testimony through you here today. Lab Request 78 being the first of the work that he did. So if you need a moment to find where that is, I believe that's in a separate binder. And this was Lab Request 78. If you could first tell us, like I've asked you about the reports you authored, what was the date where he issued this report?
September 8, 2015.
And with respect to this particular lab request, it indicates two specific item numbers, a 1020416 and 1020420, a cigarette butt and a styrofoam cup. Are those, again, two examples of just items that were collected where there might not necessarily be an owner to those items, but for whatever reason they're collected and they're requesting testing from the lab?
Yes.
And did Mr. Clemens test those items, and please tell us what conclusions he reached, as to those two items?
On the cigarette butt, the DNA profile obtained from that item gave a result at only one gender-specific marker. All other tested loci gave no results or inconclusive results. And then for the styrofoam cup, the DNA profile obtained from the styrofoam cup is a mixture of at least two individuals and can be excluded as a possible contributor to PMH.
So if I'm understanding correctly, with respect to the cigarette butt, there was not enough there to even do a comparison?
Correct.
And then the styrofoam cup was able to be excluded at whatever DNA you got off of that could be excluded from PMH.
That's correct.
Moving on to Lab Request 80. So I believe this is one of yours. Can you move?
Yes.
Okay. We heard testimony during the trial about a person by the name of Jean Lowell who was contacted by Detective McWilliams in Leal in Alabama, who provided a DNA sample. And did you have the opportunity to perform analysis on a sample for a person with that name and then compare it against PMH?
Yes.
And what was the result?
He was excluded as the major contributor to PMH.
Moving along to request 81. You are not going to find it in your binder. You will find it in the other binder. And before we talk about that, I'm going to have to ask you some similar type of questions. You testified that when you testified on December 5th of 2025, you mentioned that on the evening of February 18th, 2015, when you responded to the 8526 East Monterey Way address, that you went out there with your supervisor, Chris Kano.
That's correct.
And that at the time, she had logged items and things of that nature. You were the one doing the swabs. But at some point, was she tasked with doing serology related to a particular item of evidence?
Yes.
Now, again, similar to the questions I asked you about Steve Clemens, first of all, she was your supervisor at the time.
That's correct.
Would she also be required, given her position, especially in being a supervisor and what have you in the lab to have the requisite education that she needed for the job,
Yes,
as well as training,
correct.
as well as the requirement to participate in continuing education.
Yes,
And even though she is the supervisor, if she does any lab work, is she subject to the same administrative and technical review requirements that all the rest of you are?
yes, she is.
I know she didn't do much by the way of lab work in the case, but she did do lab request 81, where we were looking at item 1019852. The jury did hear testimony during the trial that on the final day at the 8526 address that closet doors were collected. This is specifically serology testing related to the door marked by photo marker 82. Can you tell us what conclusions she reached with respect to this serology?
Yes, blood was not identified on LP1 and LP2 interior and LP4 on the exterior of the closet door. A small red stain from the interior of the closet door failed to give chemical indications for the presence of blood.
Let me ask you if you're familiar, or we may have to refer later the jury back to LP1 and LP2. As a person who works in the lab, are those commonly referred to as, do you see those when it's referring to latent print?
Yes,
So we heard testimony from various folks from the labs who looked at prints and shoe wear and things like that, and they testified about specifically prints that were collected from the door. Is that what is being looked at for serology in this lab request?
that's correct.
Okay. We're going to take a break now from talking about lab results, and we're going to move on to what we talked about earlier in your testimony, which is after 2015, specifically April 7th of 2016, you mentioned that the Scottsdale Police Department lab switched the way interpretation was of DNA results basically was read, or written, I should say. And that's really a really bad question. Let me start over with that. You mentioned earlier in the testimony that at some point you interpreted DNA results using the traditional or binary method, and then it switched to probabilistic genotyping, and you specifically mentioned something called star mix.
That's correct.
So I think I covered with you at the beginning of your testimony earlier this morning that after lab 80, in terms of when you're actually doing DNA interpretation, subsequent labs, and I believe with respect to you, starting at lab 96, Scottsdale started reporting results using the language that comes from the probabilistic genotyping software that's used, the star mix.
That's correct.
So before we get into what star mix is and all of that good stuff, I want to do a quick refresher on DNA results. And as we move through how you analyze DNA results, I'd like you to identify for us at what point in this kind of chain of arrows that we're going to see is where we start to see a distinction between the traditional or binary way and the star mix way. Does that make sense?
Yes.
Okay. So you put together this particular slide, so I'm going to let you control this here. In terms of what we're looking at first, when we're looking at DNA results, you have an arrow here that says, are the DNA results interpretable? What does that mean?
It means, is there even enough genetic information present for me to interpret this DNA profile? So the first thing I do is look at the DNA profile and determine whether or not the results are such that I feel like I can even do any interpretation of the DNA profile that I obtained.
Now, with respect to what you're talking about here, is that something that would just be applicable when you're doing traditional or binary? Or is this something that is utilized across the board, whether it be the traditional way or the StarMix way?
It would be something I would do no matter what process I was using.
Moving on to the next part. Single source or a mixture? Tell us about that.
So then once I've decided that the DNA profile is interpretable, I will look at the profile and determine whether it is from a single individual or if it is from multiple individuals. And in this first electropharogram that you can see with the peaks that only has 2 peaks, that's the results that I would expect from a single source sample looking at only one location of the DNA. Of course, when I do this, I'm looking at the entire profile, but this is an indication of a single source profile because there's 2 peaks. And I don't know if you recall from my very first testimony, we inherit our DNA from our mother and father, so we would get 1 peak from our father and 1 peak from our mother. And since I don't see any more than 2 peaks there, then I can make an assumption that that is from a single source. That's a single source profile looking at just one locus. And then you could see in the next one, there's 4 peaks. And that means that that is potentially a mixture because I see 4 peaks and 2 potentially could be from one individual and the other 2 could be from the other individual. And looking at the peak heights, that kind of clues me in that that might be the case. I have 2 peaks that are similar peak heights, which might belong to one individual, and then 2 smaller peaks that might belong to a second individual.
And what about that last example?
That appears to me as a possible mixture of 3 individuals. You can see 1, 2, 3, 4, 5 peaks. There are some smaller peaks, but for just the demonstration of this, it appears that that might be a 3-person mixture with the 2 taller peaks belonging to one individual, and then the other 4 peaks are potentially the same height, might belong to 2 other people. So I'm looking at those loci, looking at all of those things, but looking at 21 markers total to try to determine how many contributors are in this mixture.
Now, we showed via a PowerPoint previously what an electropharogram looks like. This is a very, very basic example because they're very colorful. They got a lot of stuff on them. Another thing that we showed the jury, just so they can kind of acquaint what we're talking about, when we had a chart up for PMH, when we had the whole profile, and we're going to see it later again in the presentation, there was like a chart, like an allele chart. Do you recall what I'm talking about?
Yes.
And on that particular chart, it has all the locations identified, and then it would show the number of repeats for each of those locations.
But yes, it had the number of the alleles that were present in it.
And so when you're looking at this and you're saying one from, or half from your mother, half from your father, and then we talked about, I think, the homo versus the hetero example. When we looked at that PMH profile, I'm just going to give that top example. And I have this memorized, you may not. Do you recall that at the top of the chart, you would see for PMH that first location identified was a 1618?
Yes.
Okay. So when we're looking at these charts that you have it as examples, would one of those peaks, when we're looking at that stuff, is that what's representative? Is one of them representative of a 16 and one representative of an 18?
Correct.
So is that how we look at that electropharogram and then kind of translate that into that chart that we see?
Yes.
Okay, so you're determining whether the results are interpretable, then you're determining whether it's a single source or a mixture. Moving along, we have number of contributors. Tell us about that.
So prior to StarMix, we would report out that a mixture had at least so many individuals. We wouldn't specifically say how many, but it would basically count the number of alleles that were present at a location, divide it by 2, and that would tell you approximately how many people were in the mixture at most. Some people can share alleles and they would overlap. So prior to Star Mix, we would report out something like at least 2 contributors or at least 3 contributors. Once we move to Star Mix, the requirement is that we have to tell the software exactly how many contributors we believe is in that mixture. So the reporting would change to say that it is consistent with 2 contributors or it is consistent with 3 contributors.
So since technology is starting to take over, I mean, we hear about AI and how people are losing their jobs and everything. I want to stress the importance of your job as a DNA analyst. Even though you're using this very sophisticated software, this Star Mix, is it still your responsibility as an analyst to determine whether it was the traditional way or the Star Mix way? Are you still required to look at data and make a determination as to how many contributors there are?
Yes,
So that still falls on you. It's not software that's spitting that out.
that's correct.
Moving on to interpretation of results.
So that would be where I might determine in binary interpretation methods which locations I'm going to use, which ones I might deem inconclusive because I believe there could be dropout. This would also be where Star Mix would fall in. Once I've determined the number of contributors and I'm confident of the DNA profile and that all the peaks are allelic, that profile is the number of contributors and that profile is then entered into Star Mix.
Now, when you say the number of peaks are allelic, what does that mean to us average folks?
That sometimes there are peaks in the data that aren't allelic, they're artifacts, and they're easy to recognize by a DNA analyst because they don't look like allelic peaks. They may have a different shape, or they're located in specific spots on the DNA locations. So when interpreting the DNA profile, we ensure that the data that we are entering into Star Mix is actually allelic data.
Now, you use the term artifacts. For your work, what does that mean?
They're non-DNA peaks.
So the interpretation of results is done in either method. We discussed the differences between the traditional or binary way and then the Star Mix way. And then we have comparison to reference samples.
So once the DNA profile is entered into Star Mix and a result is obtained, we would compare the profile to a reference sample and run a likelihood ratio. That's with the Star Mix method. Previous to Star Mix, we would have the DNA profile and then just manually compare that profile to the profile from the reference sample and determine whether or not it was a match or whether they could be included in the mixture.
And then the final step here, I think, would be the one that's exclusive to Star Mix.
That's correct, at least in my laboratory. Likelihood ratios did exist prior to Star Mix, and some laboratories did that statistical method. My laboratory did not. So likelihood ratios at the Scottsdale Police Department did not start until after Star Mix was in use.
Now, the next section of the PowerPoint is going to really get into kind of what Star Mix is, what it's looking at, and things of that nature. So because that's a little bit of information, I would suggest that we do our afternoon break right
Okay,
now.
great. So ladies and gentlemen, we'll go ahead and take that break. Please remember the admonition, and we'll see you back in 15 minutes. Thank you.
Please rise for the jury.
all of it up there and let you kind of cover it for the jury.
Okay, so StarMix is, as I said previously, a probabilistic genotyping software that aids the forensic scientist to interpret complex DNA profiles and perform statistical calculations when an association is made between an evidence sample and a reference sample. This software was developed by forensic scientists in New Zealand and Australia and was used in casework there in 2012. The Scottsdale Police Department Crime Laboratory was the 10th laboratory in the United States to implement StarMix back in April 7th, 2016. And StarMix was first used in this case on May 7th, 2016.
So your lab as a whole started using it April 7th, but related to this particular case, assuming as a request came in and you were then using it, you started using it from May 7th onward.
Correct.
I'm going to put all of these points up and just have you cover them again on slide 50.
So one of the reasons, or several reasons, why we changed from what's considered traditional methods or binary methods of interpretation to StarMix, one of the main reasons is that we can do it efficiently and effectively. We can use more of the data because that StarMix is a computer program that uses complex math algorithms and math to interpret DNA using biological modeling. It considers things that an analyst can't necessarily consider when looking at the DNA profile and considering all the different ways that a mixture of people can build a mixture. It really is most useful in cases where there's low level or the DNA is very complex, meaning it has more than two contributors. There's multiple contributors in the mixture. So I just want to state that both traditional and probabilistic genotyping are both scientifically valid, and in the nation, laboratories across the U.S. are all. The move is to probabilistic genotyping, but there are still laboratories out there using binary and traditional methods.
So I want to make sure I'm understanding what you're saying with respect to that last statement. Does that mean that any results that the jury has heard about up until this point, before the implementation of StarMix in the lab, are still valid and reliable?
That's correct. You can kind of think of it as a cell phone. Like as the new models come out, they do more bells and whistles, but it always still worked as a phone. So those interpretation methods are still valid. It just, we can do more with the data with this powerful software tool.
Moving on to the next slide and how StarMix works. It looks like the software does two main things, so why don't you tell us about that?
So the first thing that StarMix does is interpreting the mixture, what in the DNA world is called deconvolution of a mixture. So that's breaking the mixture into its different components. So when a mixture is composed of numerous contributors, it kind of breaks it down into the different components. You can kind of think of it as if you had a three-person mixture and you had three puzzles, different puzzles, and they're all mixed up together, StarMix assists the analyst in kind of separating the parts of the puzzles into their own puzzle themselves instead of mixed up. And maybe some of the puzzles have some pieces missing and it isn't all 1,000 pieces of it, but StarMix helps the analyst, separate out that mixture into its different components. That's the first start of the process, and then the second step is to provide a statistical analysis of an association with an individual, and that is in the form of a likelihood ratio.
And we'll have you talk about that a little more in detail as we move on. So you mentioned that the first part is interpreting the mixtures or the deconvolution, which you gave that good example of a puzzle to explain that. So I want to talk now, or have you talk about, I should say, definitely not me, the interpretation function of the software and how that works.
So it's important to understand that the forensic scientist isn't removed from this process. So the first step that I do as the analyst, the forensic scientist of the case, is I'm still looking at that mixture. I'm still making the determination of how many contributors are in that mixture. And based on that number I tell it, StarMix then does its processing. and it will consider all the different possible contributor combinations depending on how many contributors I tell the software there is in that mixture. And then it uses things of the biological modeling, and it accounts for things like low quality DNA, when there's dropout, how much DNA each person is contributing to the mixture. It considers all of those things, and then it uses math to compare different explanations for the data to see which one best fits the actual DNA profile that I entered into StarMix. And then once StarMix has done its computing, I, as the forensic scientist, still look at the output of the StarMix and make sure that there's diagnostics on that data printout, make sure that everything looks and is within range of my expectations.
So it sounds like you, even though we have this great software, are still very important for two functions related to StarMix. One, you are responsible, and it's important for you to be able to look at the data to determine the correct amount of contributors.
That's correct.
And then second, does that last statement on this slide essentially mean we're not leaving everything to the machine? You as an analyst still need to go in and see if everything looks right.
That's correct.
You mentioned that this next part of the software does, with the second component, the statistical analysis, calculates likelihood ratios. So I want to move into slide 55, which is, what is a likelihood ratio?
So I have been giving statistics so far saying 1 in and sometimes a very large number or sometimes a small number, and that is a frequency, how frequent I expect that profile to be in the population. A likelihood ratio is something completely different. It's a statistical calculation that has two different scenarios to explain the result. So in forensic DNA analysis, the LR answers the question, under which scenario is the DNA profile better explained?
So I think you hit, and we'll see an example of this as we move forward with these slides, where you mentioned a very large number or a very small number, and I think I got that backwards, meaning the frequency in which you would see this profile in the population.
Correct. It's 1 in, if, for instance, if the number was 1 in a million, that's a very small number, 1 in 1 million. So if you had 1 million people in a room, you would expect that DNA profile, one person in that room would have that DNA profile. That is the frequency of the profile. But a likelihood ratio is not that and doesn't deal with the population. It's actually dealing with two scenarios and which one is more likely to explain the DNA data.
And I think what you were referring to was a very small number, that being the 1 in, and I was referring to the very big number part of that. So I just wanted to make sure there was clarification as to that point. So I believe this slide 56, provides a very basic explanation of what you're trying to tell the jury about in terms of scenarios. So why don't you explain what we're looking at here?
So this is a non-forensic example of a likelihood ratio, but it's a comparison of two probabilities or two scenarios. So if the chance of rain is 80%, then that means the chance of no rain is 20%. And so it's really just a fraction. You take the 80% divided by 20, and when you do that, the answer is 4. So the likelihood ratio therefore is that it's 4 times more likely to rain than not to rain.
I didn't know it did that.
Yeah, it's fine. Sorry. I thought I got rid of all the animation. Apparently, I
That
did
was our
not.
entertainment for a lot. Okay, so now let's talk about how you take that non-forensic example and apply it to what you're looking at in the forensic world. How is the likelihood ratio used for DNA? So I'm gonna,
Yeah, I thought I got rid of all of that, but apparently not.
I'm just gonna put everything up here and have you explain it. Is that there? Okay, there we go.
I believe that's it.
Okay.
So here in this example is how we would use it in DNA and forensic science. It's given the DNA profile, what is the likelihood ratio if John Smith is the contributor, That would be the first scenario. The second scenario would be, given the DNA profile, what if it was a random person unrelated in the population was the contributor? So it's two scenarios that both can't happen at the same time. The first scenario, is it John Smith is the contributor? This would be for a single source sample. Or is it a random person in the population? And if John Smith fits the profile, all those alleles are present, that would be 1 over, this is just a hypothetical number, the probability that it's an unrelated individual would be 0.000001, which gives a very large number of a likelihood ratio of 1 million. So it would be a million, I'm sorry,
That's okay, go ahead.
it would be a million times more likely, given the DNA profile, that John Smith is a contributor than if the contributor was an unrelated individual in the population.
And you're just using a random number. This is not.
Yes, this is not a case example. This is just a random number for an example.
Moving on to slide 58. I'm just gonna put everything up and have you take us through this because I think that's easier. Starting from the top, when you're reporting the likelihood ratio, if you could explain what you're looking at.
So sometimes the scenarios change depending on the case information that I have. So I just went through a single source sample, but what if it's a two-person mixture? So then the scenario might be, given the DNA profile, what is the likelihood ratio that it is John Smith and an unknown person? Because that has to account for two people, John Smith and an unknown person, over given the DNA profile that the mixture is comprised of two unknown people in the population. So that would be how the scenario would be set up for a two-person mixture, for example. Sometimes in the DNA mixture, we can also assume the presence of people. For example, in a sexual assault case, if it's a vaginal swab, I would assume that the victim is in that DNA profile since the sample was collected from that person. Therefore, I can assume an individual in both scenarios. So the third is an example of a two-person mixture where someone is assumed. So what is the chance, given the DNA evidence, what is the likelihood ratio that it is from this female person of interest and this perhaps suspect? The other scenario being, what if it is this person of interest victim and an unknown individual? And that's how I would set up the proposition.
So if I'm understanding correctly, we have the likelihood ratio when we're just looking at a single source. We'll call it suspect versus the population, a random person in the population. The next one is the suspect plus some random person in the population over all the random people in the population.
Over two random people in the population.
And then the third scenario is the assumed contributor, so let's just say a victim in a sexual assault case, the suspect, over the assumed contributor and another random person in the population.
That's correct.
So what are we looking at here?
So these are the conclusions that can be made depending on what the value of the LR is. If the value of the LR is 2 or greater, it's considered an inclusion, meaning the person is included as a possible contributor to that mixture. An exclusion would be an LR of less than 1, but 0.499 or lower. They would be automatically excluded. And then there's an LR that can be in the uninformative range, which is an LR that's between 0.5 and 1.99. So it's really in between those two ranges.
And I'm assuming when you're saying LR, you mean likelihood ratio.
I'm sorry, yes, I call it LR for short. Yes. So you can think of an uninformative as kind of, as I was saying, an inconclusive before. I can't make any determination whether they're included or excluded. The LR is uninformative.
So we're looking at these certain numbers to determine inclusion, exclusion, or simply we can't make a determination.
Or uninformative, yes.
Informative. And then after that, we're moving on to the next slide where we're talking about a verbal scale. And is this what's communicated also in your report, in the report that you author?
Yes, the verbal scale is part of the report. It is difficult, I think, to just kind of conceptualize what a number is when you're talking about two scenarios and how more likely one scenario is over the other. So therefore, we have what's considered a verbal scale, and you could see by 0 would be an exclusion, 1 would, it's actually the range I gave before, up to 2 would be uninformative, 2 to 99 would be limited support for inclusion, 100 to 9,999 would be considered moderate support for inclusion, and then 10,000 to 999,000 would be strong support for inclusion, and then the highest level of inclusion is anything greater than 1 million.
So when you use those numbers that you previously talked about, 1 over a particular number, is this similar to what we're talking about here? If that number exceeds?
No,
Okay.
no.
Can you explain what's different?
It's a completely different statistic. So when you're saying like 1 in a number, that's how frequent you expect to see that profile in the population. The likelihood ratio is how many more times likely it is that one scenario fits the data better than the other scenario.
Okay, and I believe you said that. I just wanted to make sure there was no confusion when we're talking about those numbers. Okay, so now that we talked about what star mix is, we gave non-forensic examples, things of that nature. Now I want to draw your attention to how star mix was used in this case.
Okay. So I've discussed in this case PMH. And so in this case, it was evaluated as being a mixture from 2 contributors.
And I think you mentioned earlier, you gave the example of you evaluated as 2 contributors because you saw indications of that second one,
That's correct.
but at a very, very low level.
At a very low level,
Because
yes.
you mentioned, I believe, the ratio 99 to 1.
Correct.
But for star mix purposes, did you still feel the need to include it as a mixture because you saw the indications when you're entering that information into the software?
Yes.
Okay. Tell us what we're talking about on this slide.
Okay, so as in the previous slide, you have your person of interest in the top. I've kind of used that same setup for the 3 individuals that were compared to PMH in this case. I mean, other individuals were as well, but for the victim and Alex S. and Ian Mitcham, I took that scenario of the person of interest plus an unknown contributor over the likelihood of 2 unrelated individuals in the population and plugged in like Allison Feldman as a person of interest in the first scenario. And so I did that for each individual and calculated an LR.
And we'll move forward with that. And I'm going to kind of point you back to lab request 23. In general, at the time when we talked about that, other than, we had the reference sample for Allison,
Yes.
and we had a reference sample for Alex.
Yes.
Ian Mitcham was PMH at that, or what, we didn't know who PMH was at the time.
That's correct.
And the other known reference sample you had was Ed Pfeiffer at the time. So is that why you chose to use this example? These were kind of the early on folks.
Yes.
Okay, now explain what you're doing, because you mentioned you did a scenario that included all of the people.
So if I perform the likelihood ratio incorporating Allison Feldman as a possible contributor, given the DNA profile that Allison Feldman and an unknown contributor composed the mixture as opposed to 2 unrelated individuals in the population, the LR that I calculated supports exclusion. It's less than 1. So an LR that's that many zeros is an straight out exclusion in my laboratory. So that's how I was able to exclude Allison Feldman using StarMix. I had previously done that before StarMix by just visually looking at the profile and determining that her DNA types did not match the major contributor types. But this is how, moving forward, in April 7th, 2016, we moved to performing exclusions and inclusions.
Or one of the ways you were also initially able to exclude Allison from PMH was the fact that she had XX as opposed to XY.
That is correct. It was from a male donor.
Let's talk about how you examine this related PMH specifically to Alex.
So similarly with Alex, plugging in him as given the DNA evidence, the proposition or scenario that the DNA is comprised of him and an unknown individual, as opposed to two unknown, unrelated individuals, the LR that was calculated is also an exclusion.
So just as a practical example here, based on the way you used to do things in 2015, you were able to exclude Allison the first time, as well as with StarMix.
Correct.
Same thing for Alex.
Correct.
Produce the same results.
Correct.
Moving on to PMH, who we've already learned through purposes of this PowerPoint, or we will, and we've heard testimony about it, Ian Mitcham. So let's talk about what we're looking at here.
So in the same fashion that I did the likelihood ratio for Allison and Alex S., I also calculated it for Ian Mitcham once his reference sample was obtained. And so given the DNA profile, the mixed DNA profile from that PMH is 3.52 times 10 to the 27 times more likely to be observed if it originated from EM and an unknown contributor than if it originated from two unknown contributors. And so this likelihood ratio is 3.52 octillion, which is greater than 1 million. So it is in the strongest level of support. So this LR provides very strong support that Ian Mitcham is a contributor to the DNA mixture on PMH. And 3.52 times 10 to the 27th, when written out in non-scientific notation, would be 352 followed by 25 zeros.
And then just so we're understanding the fraction that you have there, it's Ian Mitcham, and you have that little random population visual that you're using because of the indication of that person when you were talking about the 99 to 1. That's why you have that random population, a person in the random population up there.
That's correct.
Versus below, which is it being two separate randoms in the population.
Correct. I had determined that that mixture was two people.
So we talked about StarMix. We talked about the difference between how data was being interpreted in 2015 and then moving on to post-May of 2016. You're now starting to use StarMix in reports that you're generating thereafter. Is that accurate?
That's correct.
So now that we learned about the software and what it all involves, now I want to move back to the lab work that you were doing, where we're starting to see the implementation of StarMix in the way that you authored the conclusions. So let's talk about lab report. I have it listed as 96 and 96.001, and we'll talk about that in a second. Just let me know when you are there.
I have 96 pulled up.
Okay. Is 96.00001 also in there as
Yes.
well? Okay.
So it's just an amended report.
And that's what I wanted to cover with you. So can you first tell us what date 96 was authored?
96 was authored on May 17th, 2016.
And then at some point, you mentioned there was an amendment,
Yes.
or it was amended, and what was the date that it was amended?
On October 2nd, 2018.
Can you tell us why it's, because in some of the other reports, it was just 23 and then there was 23 amended. Can you tell us why this one sort of got a different designation, 96, 96.001, or is that just a way that the lab can choose to number something if it gets amended?
It's a choice that the laboratory can make. I actually got another supervisor other than Chris Kano, and that's how she preferred amended reports to be linked to the original report, was to have this underscore 0001. So it was just a preference of my supervisor at the time, the lab manager.
Okay, so in the past, when Chris Kano was your supervisor, it would just have an amended date, but it would still be lab report 23, for example.
Correct.
But now, when another supervisor came, she wanted you to designate an amended report with an underscore and a 001 or whatever that is.
That's
Okay.
correct.
And I think I neglected to put in a 0 and there's a dot instead of an underscore, so that is, I accept responsibility for that. So can you tell us what was amended from the original report on May 17th?
It appears that it was an inconclusive statement was in the report. I don't recall what, oh, I do have that other report. Hold on just one moment.
Sure.
It appears the conclusion changed for item 1038398D. And the number of contributors changed from 2 to 3. And so the statistics changed. In addition, the back side of the mirror frame, also the conclusion changed from the original report to the amended report.
Okay, and explain a scenario, or how does that happen, I guess?
It could be due to review from the original case to the amended report, because it was, the original case was prior to Star Mix. I mean, it was after Star Mix, but right after, it could have been a review of the cases that decision was made. I honestly don't recall on top of my head.
So if somebody's doing, we talked about this administrative and technical review process. If somebody is participating in that process, somebody who is doing that review of your work, how does that happen if they look at things a little bit differently? Do they later then communicate that to you, or how does that work?
It would be communicated before the release of the report, and in this case, the report was released, so it would not have been due to that scenario, that it was due to a disagreement during tech review or something like that, because that discussion would have been had before the report was released.
Okay. What happens, I guess, since this came up, what happens in a scenario, if it does happen, where two analysts might disagree?
So we have to have a process for that. Currently, it is that the technical leader would make the decision. If the decision involves the technical leader, then we would get a third analyst, either from another laboratory. When we were smaller laboratory, now we are larger, we'd get another analyst's opinion from the unit that was a qualified analyst and have their opinion kind of make that determination between the disagreement between the two analysts.
But that doesn't, so you're the technical leader.
That's correct.
Back then, were you the technical leader?
I was the technical leader back then, yes.
And so if there was some disagreement, it would go to somebody else if it was your work.
That's correct.
But you're saying in this particular case, there was an amendment made with respect to contributors and the conclusion, but it didn't have to do with a disagreement.
That's correct.
And you can tell that from the report being released information?
Correct. It wouldn't have been an amended report. That would have been taken care of during the technical review. So it was an error that was discovered after the release of the report, or a change in interpretation after the release of the report.
Okay, so let's talk about, so fair to say that when we're talking about results here, we're going to talk about results and conclusions that are going to come from 96_0001.
Yes.
Okay. You looked at various items that we have up there, A, B, C, D, E, and F, which were various swabs collected from this standing mirror that was located in Allison's kitchen.
Yes.
So if you could walk us through the conclusions that you reached when you analyzed these swabs.
Okay, so the DNA profile from 1038398A was the outward facing side of the stand. A partial DNA profile was obtained from that item, and it's consistent with the DNA. It's consistent with the DNA obtained from Feldman. DNA foreign to the victim was detected on both items. However, it is unsuitable to be searched in CODIS or compared to any reference samples due to the limited genetic information obtained.
So when you're saying unsuitable to be searched or compared, it's that limited genetic information that doesn't allow you to put it into this CODIS database.
Or make any comparisons to reference samples, yes.
Okay. And did you reach that same conclusion for item C as well in this grouping?
I did, yes.
So if I'm understanding correctly, you're seeing the presence of Allison and perhaps foreign DNA, but not enough information to do anything else.
That's correct.
Let's move on to item B and tell us what conclusion you reached there.
For item B, which was the cardboard backing of the mirror, the DNA results were obtained at only one locus and therefore unsuitable to be searched in CODIS or compared to any reference sample.
And again, is that just because you had something only at one location?
That's correct.
Moving on to item D, what were you able to determine in your analysis there?
A partial DNA profile was obtained from item D, which was the inside-facing side of stand. It was consistent with 3 individuals. Assuming that Feldman was a contributor to this mixture, it is inconclusive whether Alex S. is a contributor to the mixture because the likelihood ratio does not provide sufficient support for inclusion or exclusion. The unknown male contributor number 1 from PMH is excluded as a possible contributor. This mixture is unsuitable to be searched into CODIS. However, comparisons can be made if additional reference samples are submitted.
Let's talk about the distinction there. So before, in some of these other examples, it was unsuitable to be searched or compared. Here we're seeing a scenario where it was unsuitable to be searched, but possible for comparisons. Tell us about that distinction.
That means there was enough DNA there that I felt comparisons could still be made to another individual if law enforcement decided to submit another reference sample for me to compare.
Okay. And so essentially, you gave us the long scientific conclusion, which that's how you're supposed to report things. Is that simply saying that you're seeing Allison, it's inconclusive as to Alex, and you're able to exclude PMH?
Yes, that's what the likelihood ratio supports.
Moving on to example E, or item E, the front side edges of the frame.
For that profile, a partial DNA profile that's consistent from originating from 2 individuals was obtained. assuming that Feldman is a contributor to this mixture. The DNA profile from a former staff member of the crime lab cannot be excluded as a possible contributor.
I want to talk to you about that conclusion. First of all, were you able to identify who this staff member was?
Yes.
And who was it?
It was Jennifer Valdez.
Was Jennifer Valdez present at the 8526 East Monterey Way address, or did she have any involvement in handling things or being present at the scene?
She was not present at the scene that I'm aware. However, she did assist a latent print examiner in examining that mirror when it was in the latent print unit.
So she had contact with this item in the lab.
That's correct.
Now, you mentioned your quality control measures and things of that nature. So how were you able to determine what happened, and then how do you document it?
So in my previous testimony, I explained that the DNA profiles are searched in a staff database that have profiles from members of the lab and some profiles from law enforcement. This profile was put into that database and a hit to that employee was made. And that's how I determined that they were a contributor to that mixture.
And then what do you do?
And then depending on what the results are, sometimes I can make an assumption that that person's there so that I can still try to interpret the other components of the mixture. It really depends on how many people are in the mixture and what kind of results I attain. But in this case, it was a two-person mixture, and Feldman was assumed to be a contributor, and therefore the other person fit as possible the second contributor.
Okay. Moving on to F. It looks like that's the back side of the frame. After analysis, what did you determine there?
That the DNA profile was consistent with 3 individuals, and assuming that Feldman is a contributor to this mixture, it is inconclusive as to whether the unknown male contributor number 1 from PMH is a contributor to this mixture, because the likelihood ratio does not provide support for inclusion or exclusion, and that Alex S. is excluded as a possible contributor. This mixture was unsuitable to be searched in Dakotas. However, comparisons could be made if additional reference samples were submitted.
And I think I understood your earlier testimony, enough DNA present that if you were to get different reference samples, you could still try to compare them against what you found here.
Correct. I could attempt to get to do a likelihood ratio with that individual.
Moving on to lab request 97. First of all, if you could tell us, here's another scenario where you've received a sample to look at. Can you tell us the date that you issued this report?
June 7th, 2016.
And Lieutenant Lockerbie, also Sergeant Lockerbie, also Detective Lockerbie, throughout the pendency of everything, had arranged for a sample for a person by the name of Wilton Elrod from another case to be looked at by the lab. Did you then have the opportunity to analyze a sample for a person by that name and then compare it to PMH?
Yes,
And what was the result?
that he was excluded as the major contributor to PMH.
Moving on to lab request 98. First question again is, what date was this report issued?
June 9th, 2016.
And I want to cover with you at first what I chose to group together for the purposes of this slide, which were a few different items, which I have described as hairs. There was 1019292B, taken from Allison's left hand, 1019646, a hair taken from the guest toilet bowl, and then, or collected, I should say, 1079094B-1, a hair collected from the dining room chair. What results did you reach in this case? Or in this lab, I should say.
And no DNA profile was obtained from item, I might be looking at the wrong, 1019292B. And no DNA profile was obtained from the hair of 1079094B-1, the dining room chair.
And then what about 1019646?
The DNA profile obtained from item 1019646 is consistent with a single male individual, and a search of the Scottsdale Police Department's local database resulted in a match to Harley Feldman.
And I think we had already determined earlier on in your testimony that you had analyzed a buccal swab from Harley Feldman. So is that what you had on file that you were able to compare this to?
That's correct.
Moving on to laundry room cabinets. There's knob 1, 2, and 3. And as we're looking at the cabinets from my angle and your angle, I guess, the cabinet to the left was 1, 2 is in the middle, 3 is on the right, and we're talking about the knobs. I want to ask you about this, just to be clear. In terms of these particular 3 knobs, are these knobs that you ended up swabbing?
Yes.
When you were swabbing these knobs, you did not go to the scene to swab them.
That's correct.
Did you swab them after they were removed from the cabinets?
Yes.
So we heard testimony that on one of the latter days of processing the scene, there was a request to have all the knobs and handles, we'll call them, removed. So you then swabbed them once they were removed.
That's correct. Once they were submitted in a request, I swabbed them individually in the laboratory.
And are you aware that they were previously swabbed by crime scene specialists while they were still affixed to the cabinets?
I don't believe I realized that at the time, but yes, that is my understanding today, yes.
So you've come to learn that.
Correct.
However, your swabs of the knobs, once they were removed, it's your understanding were tested prior to the swabs that have been collected while these knobs were still affixed.
That's correct.
Moving ahead to your conclusions, so you take these knobs and you do your own swabbing. I want to ask you quickly before we talk about the conclusions, in terms of swabbing the knob itself once it's off, does that give you a better, I don't know what the right word may be, threshold to properly swab the item?
Are you asking if do I have like better
Access.
Control to the knob,
Access.
access.
Sorry.
Objection,
Okay.
speculation.
Would you mind just rephrasing? Because I heard a lot of different things going on. Could you just rephrase the question?
Based on your experience swabbing items, is it easier to swab an item like this while it's still affixed or when it's removed?
In order to get a better swabbing of the item, I would feel like it would be better to get a swab of it once it's taken off the hardware. I'm kind of short, so it might be difficult for me to swab depending on how high they are. And then that way I have full access to all sides of the knob.
And that was just kind of an aside question I wanted to ask you about, which I might ask you a little more about later. But so you just testified that you swabbed all three of these knobs after they were removed. They came into the lab. There was a request made. You did that. And what conclusions did you reach with respect to each of the three knobs?
So from laundry knob number 1, DNA results were obtained at only one locus. Actually, that was for laundry knob number 1 and laundry knob number 3, and that the results were unsuitable to be searched in CODIS or compared to any reference samples.
How about knob 2?
The DNA profile obtained from laundry knob number 2 was entered into CODIS and will be routinely searched. Let me go back. That's kind of the end all result of the report. A partial DNA profile was obtained from the laundry knob number 2, and it was consistent with originating from a single male individual. A search of the laboratory's eldest resulted in a match to item PMH.
So if I'm understanding you correctly, the same profile you had obtained from PMH was present on laundry room knob 2.
Correct, although the profile from laundry knob number 2 was a partial profile, not a full profile.
How were you able to still make that determination then? I know we learned that it was a it's the end of the day, full profile in PMH. How can you make this determination when it's a partial profile?
Because the DNA that was present did match to the DNA profile obtained from the major PMH.
One follow-up question I have about this is, as you were walking through the home, you testified that in various locations, and I believe this might have been one of the areas you had talked about, you had observed spray over on cabinets. Do you recall that part of your testimony?
Yes.
Trying to figure out how to ask this question. I'll come back to that at some point. Moving on to another set of knobs that were examined under lab request 98. There were knob 1 and 2, I believe left to right, which came off the kitchen cabinets. In this particular instance, these knobs that you examined were once they were removed.
That's correct.
So you did the swabbing.
That's correct.
And what conclusions did you reach after analysis?
The DNA profile obtained from kitchen knob number 1 is consistent with originating from 2 individuals. Assuming that Feldman is a contributor to these mixtures, Alex S. and the unknown male contributor from PMH are excluded as possible contributors.
And then knob 2?
Knob 2, the DNA profile obtained from kitchen knob number 2 is consistent with 3 individuals. Assuming Feldman is a contributor to this mixture, it is 9.32 times 10 to the 14 times more likely to obtain the DNA results if Alex S. is a contributor than if he is not a contributor. The unknown male contributor from item PMH is excluded as a possible contributor.
I know you have the very scientific, like we mentioned, or conclusion written there. Is that basically telling us in terms of likelihood ratios that the likelihood ratio would support Allison and Alex being present and not PMH?
Yes, the likelihood ratio supports the inclusion of Feldman and Alex and the exclusion of PMH.
Okay. And was this another one of the areas when you were walking the home that you and others had observed spray over on?
Yes.
Moving on to the dresser drawers, still part of lab request 98. This slide includes the first 6. The slide we will cover subsequently, I believe, will contain the remaining 6. Again, were these knobs that you swabbed once they were removed from the actual dresser itself?
Yes.
Let's talk about the conclusions you reached with respect to knobs 1 through 6.
Sorry, I'm trying to find the results for dresser knob number 1.
I know these reports can be pretty meaty.
Okay, so for dresser number 1, no DNA foreign to Feldman was obtained from dresser knob number 1 at all genetic loci tested.
Meaning Allison is the assumed contributor?
That only one contributor was detected, and yes, it's assumed that Allison Feldman is that contributor.
And so nobody foreign to her on knob 1.
That is correct.
How about knobs 2 and 3? It appears that they have a similar conclusion. If you look on page
Okay.
that's page 2.
The DNA results were obtained at only one locus for item dresser knob number 2 and dresser knob number 3. And these results are unsuitable to be searched in CODIS or compared to any reference samples.
Is that again a situation where there's just not enough information?
That's correct. Only DNA at one of the locations was detected.
Moving on to knobs 4 and 5, which I believe also shared similar type conclusions. What did you find there?
The partial DNA profiles obtained from dresser number 4 and dresser number 5 are consistent with originating from 2 individuals. Assuming Feldman is a contributor to this mixture, it is inconclusive as to whether Alex S. and the unknown male contributor from PMH are contributors to this mixture because the likelihood ratios do not provide sufficient support for inclusion or exclusion.
And then finally, knob 6.
A partial DNA profile was obtained from dresser knob number 6. It's consistent with originating from 2 individuals. Assuming Feldman is a contributor to this mixture, it is 3.33 times 10 to the third times more likely to obtain the DNA results if Alex S. is a contributor than if he is not a contributor. The unknown male contributor from item PMH is excluded as a possible contributor.
So the likelihood ratio is telling you, showing support that Allison and Alex are present on that knob.
The likelihood ratio, yes, is providing inclusionary strength that I assumed that Feldman was a contributor to that mixture. And the likelihood ratio does provide support for inclusion for Alex S.
Moving on to knobs 7 through 12, let's talk about those results.
So for dresser number 7 and dresser number 9, no DNA profile was obtained.
How about 8? And that's on page 4. About halfway down.
The DNA profile obtained from dresser knob 8 is consistent with originating from 2 individuals. It is 9.22 times 10 to the 24 times more likely to obtain the DNA results if Alex S. is a contributor than if he is not a contributor. It is inconclusive as to whether Feldman is a contributor to this mixture because the likelihood ratio does not provide sufficient support for inclusion or exclusion. The unknown male contributor from item PMH is excluded as a possible contributor.
Let's look at knob 10, which I believe is discussed in the paragraph below.
The partial DNA profile obtained from dresser knob number 10 is consistent with originating from 2 individuals. It is inconclusive as to whether Feldman, Alex S., and the unknown male contributor from PMH are contributors to this mixture because the likelihood ratio results do not provide sufficient support for inclusion or exclusion.
Moving on to 11.
The partial DNA profile obtained from dresser knob number 11 is consistent with originating from 2 individuals. Assuming that Feldman is a contributor to this mixture, Alex S. and the unknown male contributor from PMH are excluded as possible contributors.
And then finally, knob 12. Which is on page 4, top paragraph. It's mixed with a few of the other items.
A partial DNA profile was obtained from dresser knob number 12 is consistent with originating from 2 individuals. Assuming Feldman is a contributor to this mixture, it is inconclusive as to whether Alex S. and the unknown male contributor from PMH are contributors to this mixture because the likelihood ratio results do not provide sufficient support for inclusion or exclusion.
Ms. Beamer, as you made your way through the house, I think you testified again earlier, was this dresser item one of the items where you observed spray over?
Yes.
And then finally, I want to talk about the nightstand. Which knobs 1, 2, and 3, like the other items, did you have these knobs in your possession after they were removed?
Yes,
So you did the swabs.
that is correct.
And what were the conclusions you reached there?
The DNA profile obtained from the nightstand knob number 1 is consistent with originating from 2 individuals. Assuming Feldman is a contributor to this mixture, Alex S. and the unknown male contributor from PMH are excluded as possible contributors.
And then how about knob 2?
The partial DNA profile obtained from nightstand knob number 2 is consistent with originating from 2 individuals. Assuming that Feldman is a contributor to these mixtures, Alex S. and the unknown male contributor from PMH are excluded as possible contributors.
And then what conclusion did you reach with respect to knob 3?
No DNA foreign to Feldman was obtained from the partial DNA profile obtained from nightstand knob number 3.
And in this particular example, again, is Allison an assumed contributor?
Yes.
The final component of lab request 98, which will then be a good stopping point for us today, is a series of hairs removed from the living room floor. A, B, C, D. There's not an E referenced here. There's just an F and a G. So it appears there were 6 hairs collected that you were provided. Let's talk about what, if any, conclusions you reached with respect to those.
So no DNA profile was obtained from the hair from the living room floor, which was 98A, 98F, or 98C.
How about G?
Again, no DNA profile was obtained from 98G.
How about 98B?
The DNA profile obtained from item 1020198B is consistent with originating from a single male contributor. It is 7.07 times 10 to the 24 times more likely to obtain the DNA results if Alex S. is a contributor than if he is not a contributor.
And then how about D?
The partial DNA profile obtained from item 1020198D is consistent with originating from a single individual. It is 4.91 times 10 to the 4th times more likely to obtain the DNA results if Feldman is a contributor than if she is not a contributor.
And these stats that you provided as examples for B and D, are those stats that have the very strong support for the very strong support?
No, actually, for D, it's very strong support for inclusion.
Okay, and what about B?
For B, it's very strong support. The likelihood ratio, it was 7.07 times, 7.07 times 10 to the 24 times more likely to obtain the results if Alex S. is a contributor than if he is not a contributor.
Okay, meaning the hair, we interpret that to mean that appears to be Alex's hair, that appears to be Allison's hair, based on your,
The likelihood ratio supports inclusion of Alex S.
okay. I think this is a good point.
Okay. Ladies and gentlemen, we'll go ahead and break for the evening. Please remember that admonition as you go home tonight. As always, please do not watch any news stories about this case if there are any, or read any news stories. Please don't talk to your friends and families about the case. Don't do any kind of independent research, and we'll look forward to seeing you back here tomorrow at 10:30. Have a nice evening, and thank you for your service.
Please rise for